So now we're going to take a look at switching between the Poisson and exponential distribution. And this happens quite a lot in questions, as I explained before, because the exponential distribution is the distance or the time between our Poisson events. So if we have the mean of a Poisson event, which is lambda, and remember that in this case the mean is the same as the variance, which is the same as lambda, then the parameter of the exponential distribution is going to be the time interval divided by the mean number of events. So we need to be careful here. What this is saying is, if we have, let's say, a Poisson distribution where we have x following the Poisson distribution with a mean or a lambda of 3, and this 3 is per hour, then the mean of the exponential distribution is going to be 1 over that. Now, because quite a lot of the times this is to do with time, we have two choices at this point. We can either have a look in terms of hours or in terms of minutes. So what I tend to do is I tend to check what the future part of the questions are using, and I change my distribution to match that. So if I was given the Poisson distribution with 3 per hour, and then in part A it says what's the probability that they have to wait less than 20 minutes, then I would go for the minutes option. But if it said 3 per hour, what's the probability that they have to wait more than 1 hour, I would tend to go with the hour. So it depends on the future parts of the question as to whether I'd suggest going for hours or going for minutes. So if we were going for hours, then our mean would be, well, it's 1 hour, because this is per hour, divided by 3, because that's the number of events. If, however, we were working in terms of minutes, then our mean time between them would be, well, there's 60 minutes in an hour. In that time, we have 3 events, so that would be 20 minutes. So this is 1/3 of an hour, or 20 minutes. And if you know your time correctly, then you can see that they are the same as each other. But this determines what we use when we're having a look at our exponential distribution. So the parameter, if we were going for hours, then x follows the exponential distribution. And if you remember about in the last video where we had the mean come up in there, I said that the parameter was 1 over the mean, which means that this would go back to 3. However, the mean here is 20, which means that then we would have x follows the exponential distribution with a parameter of 1 over 20. Now, this is going to end up giving us the same answers if we were to work in terms of hours or minutes. Just as an example of that, so if we had, let's say, a part of a question which said less than 2 minutes, so here we would have less than 20 minutes, until the next event. On this side here, because 20 minutes is 1/3 of an hour, we'd look at the probability of x being less than 1/3 of an hour, which would give us 1 minus e to the minus, here our lambda is 3, times 1/3, because we're looking at 20 minutes, which is 1/3 of an hour, which gives us 0.632. If we wanted to work in terms of minutes, because we're saying less than 20 minutes, and this is already in terms of minutes, we don't need to change that bit. And then we'd be looking at 1 minus e to the minus 1 over 20 times 20, which gives us 0.632 again. If instead of 20 minutes it was half an hour, so if we were keeping in terms of hours, that would be half an hour. If we're keeping in terms of minutes, that would then be 30 minutes. And you can see there that you're still getting the same probabilities. I've just done that in my calculator. I haven't written it down. But you can see there the link between them, and that's very important. And it's usually this one, this am I working in hours or am I working in minutes, that people get confused between. So just be careful. Decide at the beginning, have a look through the questions and the parts of the questions and decide, is it going to be easier for me to work in terms of hours, or is it going to be easier for me to work in terms of minutes? And then from then on, you're either going to have to convert everything into hours or convert everything into minutes. So as I was saying here, the mean is 1 over lambda. So if we know the mean, to find lambda, we have to do 1 over the mean. If it's asking for the mean and we know what lambda is, then we're having to do 1 over lambda to get the mean. The variance is 1 over lambda squared. Now this is quite important, especially if you end up deciding to work in minutes, okay? So the mean is the variance, is actually, so here our variance, what this is actually meaning is that it's going to be our mean squared. So if we have 20 as our mean, then our variance is going to be 20 squared. So that means that in this case, our standard deviation, because that's going to be the square root of this, we're going to go back to having 1 over lambda, which means that for the exponential distribution, the mean is the same as the standard deviation. And this gets a lot of people confused, because with the Poisson distribution, the mean is the same as the variance. With the exponential distribution, the mean is the same as the Poisson, as the standard deviation, and that's the difference between them. So you need to be careful with that and remember it. In your formula booklet, however, on page 5, it does tell you that the exponential mean is 1 over lambda, the exponential variance is 1 over lambda squared. So if you remember to have a look in your formula booklet at page 5, you can see that for Poisson, again on page 5, it says Poisson, the mean is lambda, Poisson variance equals lambda. Whereas for the exponential, it says Poisson mean equals 1 over lambda, Poisson variance equals 1 over lambda squared. But as I said, if you decide to work in a different unit in terms of, like, let's say minutes, and you end up with a number, then just remember that it is the mean squared. So if you get confused about that, just refer back to that. So we're going to have a look at some examples. So here we have the time between Poisson events is 2 hours. So this is telling us that the mean is 2 hours between events. And then we're having to find probabilities. So we're going from the mean time between these Poisson events to using the exponential. So again, similar to what we had a look at in the last section where it said the word mean, our parameter, our lambda, is going to be 1 over 2. So we're going to be using x follows the exponential distribution with parameter of 1/2. So we're trying to find the time until the next event. We're finding the probability that the time until the next event is less than 1.5 hours. So because here, this said hours, I've kept this in terms of hours. So when it says less than 1.5 hours, I'm going to have to keep that as 1.5. So probability that x is less than 1.5. Now, if I change that to minutes, if here I had, instead of using the mean being 2 hours, if I changed that to mean being 120 minutes, then this would have here been 1 over 120 minutes. So then here that would be 1 over 120 minutes. And then here I'd be looking at 90 minutes. Okay. So as I said, if you've gone for minutes instead, we'd have x follows the exponential distribution with 1 over 120. And then we'll be looking at the probability that x is less than 90 minutes. So for this top one, for in the one in purple, we'd have 1 minus e to the minus lambda, which is a half, times our 1.5 or 1.5. So that's 1 minus e to the minus a half times 1.5, which gives us 0.528. If you went for minutes instead, then we'd have 1 minus e to the minus 1 over 120 times 90. So that would give us 1 minus e to the minus 1 over 120 times 90, which you can see still gives us the same answer, 0.528. I'm not going to do this for all the questions. I'm just doing it a little bit to show you that it works no matter what you're working with, as long as you're consistent, either working in hours or working in minutes. So for B, we're looking at the time until the next event will be more than an hour. So I'm just going to do this in terms of hours now. So we're looking at the probability that x is more than 1 hour, which is going to be 1 minus the probability of x being less than or equal to 1 hour, which gives us 1 minus e to the minus a half times 1. So that's 1 minus, important bracket there, 1 minus e to the minus a half times 1, which gives us 0.607. So then, part C, the time until the next event will be between 1 and 2 hours. So there we're looking at the probability of x being less than 2 minus the probability of x being less than or equal to 1. So that's looking at the probability that 1 is less than x is less than 2, which gives us 1 minus e to the minus 0.5, a half, sorry, putting the wrong thing there. So minus a half times 2 minus 1 minus e to the minus a half times 1. And that gives us 0.239. For part D, if the last event happened 2 hours ago, what is the probability that the next one will occur in less than an hour? Well, if you remember from the previous section, we said that the exponential distribution has no memory. So we don't care that 2 hours has passed. We only care about what is the probability that the next event will occur in less than an hour. So we're just looking at the probability that x is less than 1, which would give us 1 minus e to the minus a half times 1. Which gives us 0.393. So for that first question, I would have suggested to just keep working in hours. All the questions referred to hours, so it would have been dead easy just to keep things in terms of hours. So then for question 2, we've got the number of mistakes made by a typist is 20 per hour. So the number of mistakes is our Poisson distribution. So this bit here is x follows the Poisson distribution with a mean number of 20, and this is per hour. So that's quite important to make sure that you read the information that you're given correctly and identify it, because we're talking about the number of mistakes, not the time between the mistakes. That is the Poisson part, okay? This is the number of mistakes. You can only make a whole number of mistakes, so it's not continuous. It's definitely going to be the Poisson part of our distribution. So then for A here, we're looking at the mean time between those mistakes. And looking further down here, I can see minutes. So this time I'm going to work in terms of minutes because here we're talking about minutes again. So we have our mean is going to be our 1 hour, which is 60 minutes, divided by the number of mistakes, which is 20, which gives us 3 minutes between our mistakes. If you had decided to keep it in terms of hours, then we would have had 1 over 20 hours. So then, what is the variance? Well, as I said, the variance is just going to be the mean squared. So if we're keeping this in terms of minutes, then we're going to have 3 squared, which gives us 9 minutes. If you had this in terms of hours, we'd have 1 over 20 squared, which would give us 1 over 400 hours. And then for part C, we have what is the probability that the typist makes no mistakes in a 40-minute time period. So like I said, that's why I'd keep this in terms of minutes, because it talks about minutes down here. So because I have my mean here in terms of minutes, that means that my exponential distribution is going to be x follows the exponential distribution with a parameter of 1 over 3. Sorry, that's gone a bit wonky. 1 over 3. So then I'd be looking at the probability that x is less than 40, which would give me 1 minus e to the minus 1 over 3 times 40. So 1 minus e to the power of minus a third times 40, which gives me 0.99999838804. If you had decided to work in terms of hours, then we would be working with x follows the exponential distribution with a parameter of 20. We'd be looking at the probability that x is less than 2/3. As, like I said, we're keeping this in terms of hours. So then we would have 1 minus e to the minus 20 times 2/3. So 1 minus e to the minus 2/3 times 20. Sorry, I wrote that the wrong way around. And you can see there that we've ended up with the same answer. So make sure that you're being consistent. I've shown both of them just to show you that you end up with the same answer no matter which way around you do it. Yes, your mean and your variance are different, but that's because your units are different. So one of them is representing minutes, one of them is representing hours. So I'd like you to go on to the Now You Try questions. Be very careful, read the situation carefully, decide if you've been given a Poisson or straight away into the exponential, and then work from there. Okay, so hopefully you've taken the time to pause the video and try the Now You Try question. So here we had in 10 metre length of fabric, there are an average 4 mistakes. So this is why, if I just go back one step, here in the introduction part, I've put, however, it is more accurate to say that we're going to do, for the exponential distribution, it's going to be the interval for the Poisson distribution divided by our lambda. And the reason why I said that is because here, when we're having a look at our mean, we have find the average distance between the mistakes. So in 10 metres, there are 4 mistakes. So it's not going to be 1 over 4, because we're not looking at 1 metre. It's going to be 10 over 4, which gives us 2.5. Now, if that confuses you, then the alternative way to remember it is to remember it as 1 over lambda. But remember that here you are going to have to change this first to give us 1 metre. So if I went from 10 metres to 1 metre, I would have to divide by 10. So I would end up with 0.4 instead of 4. And then for my mean, I would have 1 over lambda, which is 1 over 0.4. And if I did 1 divided by 0.4, you can see that you still end up with 2.5 meters. So it's your decision whether you want to keep it is the 10 meters, but just remember that because it's 10 meters, you do 10 divided by 4, or always convert it to 1 meter or 1 unit of whatever we're looking at, and then do 1 divided by lambda. That's up to you. Like I've just shown you, you end up with the same value. The variance is going to be our mean squared, so no matter which way you decided to do that first part, you end up with 2.5 squared, which gives us 6.25. And then, because our mean is 2.5, our distribution is going to be x follows the exponential distribution with a parameter of 1 over 2.5. And then we're looking at the problem, because it says here, if a mistake has not been made in the first 2 meters, so we can ignore that because that's been and gone. The exponential distribution has no memory. We can ignore that part. What is the probability that it will not be a mistake in the next 2 meters? So we want it to be more than 2 meters until the next mistake. So we're just looking at the probability that x is more than 2, which gives us 1 minus bracket 1 minus e to the minus 1 over 2.5 times 2, which, as you can just about see in my calculator here still, gives us 0.449. So always be careful when you're converting between Poisson and exponential distributions. Read it carefully. Always check, have I been given the parameter for the Poisson, or have I been given the parameter for the exponential? Have I been given the mean for the Poisson, which yes is the same as the parameter, or have I been given the mean for the exponential, which remember that then to get the parameter you're going to have to do 1 divided by that. In the Poisson distribution, the mean is the same as the variance, but in the exponential distribution, the mean is the same as the standard deviation. So there's quite a few things there that you have to be careful with, on top of the exponential distribution has no memory, and the fact that it's a continuous distribution, so the strict inequalities and less than or equal to, greater than or equal to signs have the same, not only working, but they're going to give you the same numerical answer, and also that means that the probability of x equaling any exact value is going to be 0. Thank you very much for listening.